So in the last video we talked about how different mountains form and how the accretion process, including all the different kinds of collision boundaries, are going to be responsible for forming mountains. Alright? And on this video we're just going to be talking about the different kinds of mountains that happen because of these collisions. And I encourage you to review the mountain formation video as well as the features of convergent boundary videos before you actually watch this, okay? Because you're going to need that. This video is just about the types of mountains. So I'm not going to be really talking about how mountains form. I'm going to be focusing more on what mountains exist. Okay, so the first kind of mountain I wanted to talk about are folded mountains. Now these are the general kinds of mountains that form whenever those collision events take place, and that's basically because the uplift that happens because of the crust being compressed. And usually these folded mountains are going to have downtops or roots underneath them, because remember, when you make the crust a little more dense, you're going to end up creating a subsidence of the lithosphere underneath it, unless of course there's a stronger magma intensity underneath those mountains, the way it usually happens in places like Sierra Nevada, for example, where the asthenosphere is thinner and very buoyant, pushing the lithosphere higher. So you can have folded mountains because of that as well. But either way, folded mountains are those general kinds of mountains that you think about, and those are basically synclines and anticlines all put together into like these folds. As you can see in the picture on the top left here, you have synclines and anticlines. Now here you see some examples of places in the world where these folded mountains are going to be around. They are marked locations of basically all of the collisions that happened because of continents a long time ago. Some that formed because of Pangaea's formation, and others which are forming still because of collisions which are happening now. So you see all this southern Europe mountain system here, the Rocky Mountains, the Himalayas, more of the southern Europe here, the Alps, the Andes, and a lot of other mountains are formed because of collision events. And so remember, collision events are going to be creating mountains. Now another kind of mountain that has to do with collision events, but this will happen when a collision will take place at the same time that a divergent boundary or a transform boundary takes place, is that you have the folded mountain form, but then the folded mountain will crack, and then you will get something that looks like this. We call them fault block mountains. And basically you see that there used to be a mountain that was here connected to the mountain that was here, but a big gap opened between them. In this case you could call this a graben, right? And that will be called a horst. Remember we talked about this? And that happened because the area that used to be a mountain range now was cracked open, and so you get what is called a fault block mountain. And this will happen when a mountain either shifts upwards or downwards because of tectonic plate motion after the folding take place. So think of it this way: folded mountains which are subsequently cracked and shifted either sideways or upwards in relationship to the other block of the mountain are called fault block mountains. And this will happen along the edges of transform boundaries or divergent boundaries, and sometimes even because of truss faulting that will happen in the convergent boundaries as well. So whenever you have a mountain range that cracks right in the middle of the mountain range and then shifts because of fault action, you're going to have what I call a fault block mountain. All right, and these are those examples. Now you also have dome mountains, and those are usually happening because of either tectonic or volcanic action that actually pushes the surface higher in a dome shape, which is a three-dimensional fold where all pieces of the fold converge towards the center. And this will happen because of tectonic pressure on both sides, kind of like the same thing as a folded mountain, but they will tend to be isolated instead of happening in a series of synclines and antisynclines the way it happens with a mountain range. And a lot of times they are tectonic, like the ones you see in the board here. And you also might have them be volcanic, like the ones you see here. Volcanic dome mountains will happen whenever you have a large lava plume kind of rising on the ground because of stronger volcanic action that's taking place. And sometimes we call those plutons when they get exposed to the surface. You see one right there, and it's almost just shy of a plateau because it's just plateau because it's not a flat on top, but these are extremely large dome mountains which are caused because of lava pushing from the bottom. So remember, you can have tectonic plate folding the earth, you can have subsidence and uplift happening because of the changes in the weight of the surface, and in this case you can also have the formation of domes. Now this one in particular is actually very interesting because you have a dome mountain that has a basin on top. So that's actually very interesting how at first it got uplifted, but then maybe the magma gave up, and then subsequently that caused the falling of the ground in later on. So as you go, you have the down mountains. And the ones that I showed before were the tectonic ones. This is the plutonic ones, which are caused because of volcanic action. Now, while I'm in the subject of dome mountains, I would like to say that sometimes people refer to what's called an upwarp mountain, and that can be anything, like a folded mountain, a dome mountain, or a fault block mountain. It's just basically referring to any time that an uplift event takes place in the surface of the earth. Usually that happens because of either tectonic pressure from both sides compressing the crust, or because of uplift being caused by hotter magma activity, or basically a hot magma plume or a hot spot that actually creates these domes that we talked about here. All right. Another kind of mountain that's actually have very similar or a lot to do with the dome mountain is an actual volcanic mountain. And this will happen when a volcano actually pierces the surface and it causes these large volcanic mountains as you see here. Volcanic mountains are protrusions of lava that basically sits in the surface of the earth almost, where the magma is trying to punch to the surface and eventually actually does. And they tend to be very, very tall, and you see how they have snow on the tops of them. And you see some of the very most famous ones here, including Mount St. Helens, Vesuvius, Kilimanjaro, and Mount Rainier, and Fiji Mountain in Japan. So you have several of the most famous volcanoes, mountains shown here. And these are what we call composite volcanoes, and we'll talk more about it on the next video. But basically they are mountains caused by volcanic activity. And you also have some other volcanic mountains which are not really like that. They're not really stratified volcanoes or composite volcanoes, but they're more like shield volcanoes, which happen more because of lava flows gathering over long periods of time. And you see the shield volcanoes here. And then you also have volcanoes like the Aleutian Island volcanoes that you can see here. And it's kind of like a in between both of them. So either way, there are several kinds of volcanic mountains, which are mountains created by volcanic activity. You also have eroded mountains, which are mountains which were created a long time ago, but that changed because of erosion activity. So these could be either folded mountains, fault block mountains, dome mountains, upwarp mountains, volcanic mountains, any kind of mountain that actually changes because of erosion. And you see these happening here, and these are examples of that. In fact, the one that I actually showed you here is not really an example of a shield or a volcanic province that changed, but more like an actual platform that was eroded, right? So you get that as well. But the typical type of mountain that we refer to when we mean eroded mountain, we mean this one. For example, the Appalachian Mountains here in the U.S. These four mountains formed when Pangea formed over 300 million years ago. By now, these mountains have been eroded, and the top of them is covered with soil, which now allows trees to grow, which actually has slowed down the process of erosion, which is why we still have these mountains around, because by now they should have been eroded since they started so long ago. But the Appalachian Mountains are basically eroded mountains that used to be those very, very steep fold mountains that we see on the Rocky Mountains or Sierra Nevada, but by now they've become softer of erosion processes that actually add a soil, allowing plants to grow, and then subsequently slow down the erosion process. All right. Another kind of interesting mountain, and we call that the Plateau Mountains, and you see some plateaus here. And plateaus will form for two reasons. They will form because of erosion. So sometimes rivers will create plateaus as they carve through the surface. An example of that is the Colorado Plateau, which forms because a river kind of carves through it. But either then, the whole thing is actually an uplifted lava field. Imagine, for example, that you have the ground like this, and that underneath the lava, you have the ground, you have a very large magma chamber sitting underneath the ground. Now, if this uplift event happens, say, for example, the crust is becoming lighter, or because the magma activity is increasing, or because you're having compression from both sides here that's causing this ground to be uplifted, it is possible that that lava field will basically rise slowly to the surface and form a plateau. And so that is what actually makes these beautiful structures, which we call plateaus. Now, sometimes the plateaus themselves might be eroded and form undulating structures like you see here happening on this particular plateau there. But other times you're going to have the plateau kind of dip, the strike and dip thing that we talked about, so you can see that happening there. You also have plateaus being carved by erosion of rivers, like you see in the Colorado River Plateau. But either way, plateaus are volcanic lava fields which are pushed upwards by uplift events. So it's actually very interesting. Here you see a few more examples of plateaus, and you see the erosion of pattern that happens in the Colorado River because of wind and river action, which basically carved and collided or landslided this plateau over long periods of time. But these plateaus originally formed because of an uplift of the volcanic action. And you see this large plateau here as well, all the plateaus there. Now notice how plateaus tend to happen close to volcanic mountains, and this is actually very true for the plateau that forms near the Rocky Mountains up in western U.S., because the same uplift event that caused the Rocky Mountains ends up causing the plateau. So it's a good explanation for why plateaus usually form near the mountain formation processes. But they could happen somewhere else whenever uplift raises a large magma field higher. In addition to these plateaus, you also have another type of mountain that's formed because of divergent boundaries, and those are the famous horst and grabens. Remember that because of the divergence that's taking place, the bottom is moving with plastic flow, but the top is cracking, and as the bottom moves away, it kind of like flattens the bottom, which means it leaves less support for the top, so it makes it even more likely to crack, and then certain pieces will collapse while other pieces will stay where they were, and so those hanging walls will become grabens and the foot walls will become horsts, and you have this alternating pattern of up and down, which is not really a syncline or anticline. Usually they look like a series of plateaus basically next to each other, and that's not really plateaus the way the plateaus thought of, because remember, plateaus are formed by uplift of magma fields. This is more like a piece of rock that used to be flat that basically had certain pieces of it collapsing because of extensions on the crust. Now the areas more far away from the actual divergence will form half grabens, or things which are not really large stretches of ground, but more like it's like a graben that's kind of starting or not being stretched up as much as the big graben that's happening near the divergence zone that's actually taking place. And along the lines of this, sometimes along the edges of mountains, you also can have basins and ranges. Because a basin will be any time you have a large mountain being uplifted, while in a graben will be, if it's really large, you call that a basin. So a range is called any time that you have this large uplift material, and in a basin is any time you have this down material. So for example, when you look at the Rocky Mountains, you're going to have these extremely high Rocky Mountains, and then you're going to have a basin, and then you have another series of mountains, then the basin, and then you're going to have other. And so these kind of look like the horst and grabens that we talked about before. So horst will be the range will be the large mountain range or the large uplifted material, and then the basin would be the material that's kind of falling down, and as these mountains are kind of pushed away from each other. All right. So large grabens are called basins, large horsts are called ranges. All right, and sometimes you use this to refer to mountain ranges with large valleys in between as well. All right, so both divergent and convergent boundaries have this terminology you apply to them. The one you see in the board is an example of the terminology being applied to the divergent boundary, but you can also apply this same concept to a convergent boundary. And also, around the edges of actual mountain ranges, you often have ridges. Now, ridges are large foldings that happen because of the mountain that's collapsing, and also because of all the thrusting that's taking place. So it's very common to find these tiny little synclines and intersynclines near the edge of large mountain ranges. We call those ridges. An example of that is near the Alps. You might get those tiny ridges around the outside of the mountain, as you can see here. And that will happen anytime two plates are colliding and causing those thrusts to take place. And by the way, it looks like how you see a range here followed by basin. So ranges are usually associated with uplifted material, and basins are associated with large areas of subsided material. Another kind of ridge is the ridges that actually form at mid-ocean ridges. And again, see, just like convergent boundaries form ridges because of the thrusting, divergent boundaries form ridges because of the fracture zone, which is basically pushing more and more the ground to the sides, which is basically compressing the ground if you think about it. And so you're going to create these ridges. A very common example of that is Iceland, where you will have these mountain ranges on to both sides of the rift. And so we call those ridges, like the mid-ocean ridge, for example. And it's cool that Iceland actually has this ridge visible to the surface, and you can actually see that Iceland kind of cracked in half like this around the entire surface of Iceland, because it's basically a large igneous province that's forming at the middle of a ridge. Remember, these large igneous provinces can also happen because of hotspots, which are large magma plumes rising to the surface, which also forms new ground and new mountains. All right, which are usually volcanic mountains. So that's a review of the different kinds of mountains. We have folded mountains, fault block mountains, dome mountains, upwarp mountains, volcanic mountains, eroded mountains, plateaus, horsts, grabens, ridges, and hotspot mountains. And I hope you understand all of these. If not, you can watch the video again. And this concludes our discussion about deformations of the crust. See you in volcanoes.